and welcome to tonight's Space Sleep story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight, we embark on a journey to the twilight zone of our solar system, the Kuiper belt, a vast region of frozen worlds orbiting in eternal darkness beyond Neptune. So settle into your most comfortable position, close your eyes, and prepare to drift outward to the edge of the solar system. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. With each breath, you drift deeper into relaxation, preparing for our journey to the distant frozen realm, where sunlight fades to starlight. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls, how the air fills your lungs completely. Let my voice be your guide. Hold this peaceful moment. Feel the stress of the day leaving your body with each exhale. We're preparing to travel 5 billion kilometers from home to a realm of cold and darkness that preserves the solar system's ancient past. We begin our journey by leaving familiar territory behind. We've traveled beyond the terrestrial planets, Mercury, Venus, Earth, and Mars. We've passed the gas giants, Jupiter and Saturn. Now we cross Neptune's orbit at 30 astronomical units from the Sun, 4.5 billion kilometers. This is the last major planet, the final checkpoint before entering the Kuiper belt. Everything changes here in this twilight zone. At 40 astronomical units, the average Kuiper belt distance, sunlight takes 5.5 hours to arrive. Compare this to 8 minutes for Earth. This means observers here see the Sun's position 5.5 hours in the past. A radio signal from a spacecraft exploring this region requires 4.5 hours to reach Earth, traveling at light speed. Communication operates at cosmic patience here. The sun still dominates the sky, but everything has changed. At this distance, sunlight is 1/1600th as bright as at Earth. The sun appears as a brilliant star, still far brighter than any other, but provides only 0.06% of the illumination we experience at home. The sky remains perpetually dark enough to see stars clearly at midday. No blue sky, just black space with a brilliant solar point source. Temperature defines this realm with absolute clarity. Surface temperatures in the Kuiper belt average 40 to 50 Kelvin, -230 to -220 degrees Celsius. Only 40 to 50 degrees above absolute zero. At these temperatures, nitrogen, methane, and carbon monoxide freeze solid. Even substances we consider gases become ice here. Water ice has the consistency of granite rock in this deep freeze. Orbital periods here stretch beyond human comprehension. Objects at 40 astronomical units require approximately 250 Earth years to complete one orbit. Pluto's orbital period measures exactly 248 years. These worlds have completed only 18 or 19 orbits since the solar system's formation 4.6 billion years ago. Some extremely distant objects have orbital periods exceeding 1,000 years, observed less than 1,000th of a single orbit in all human history. The Kuiper belt itself forms a donut-shaped region extending from Neptune's orbit at 30 astronomical units to approximately 50 astronomical units. This region contains hundreds of thousands of objects larger than 100 kilometers in diameter. Some estimates suggest over 100,000 bodies of this size, with total mass approximately 1/10 to 1/3 Earth's mass. This isn't empty space. This is a populated frontier of frozen worlds. And now we approach the premier dwarf planet of this realm. Pluto appears ahead, growing from a point of light to a resolved disk. Diameter 2,377 kilometers, about 2/3 the Moon's diameter, 1/6 Earth's. Mass 1.3 times 10 to the 22nd kilograms, 1/6 the Moon's mass, 1/400th Earth's. Surface gravity just 0.063 g. A human weighing 100 kilograms on Earth weighs 6.3 kilograms here. Small by planetary standards, but remarkably complex, as we're about to discover. Pluto possesses a tenuous nitrogen atmosphere with surface pressure only 10 microbars, 100,000th of Earth's. This atmosphere freezes and falls as snow when Pluto recedes from the Sun during its 248-year orbit. Then it sublimes back to gas during closer approach, creating a seasonal cycle spanning multiple human lifetimes. The story of how we found this distant world begins with human determination. Percival Lowell, wealthy astronomer, mathematically predicted Planet X beyond Neptune between 1906 and 1916. He based predictions on perceived perturbations in Uranus's and Neptune's orbits. Lowell spent the final decade of his life searching unsuccessfully. Ironically, the perturbations were later revealed as observational errors, and Pluto's tiny mass couldn't cause the predicted effects. Lowell died in 1916, 14 years before discovery. On February 18th, 1930, the 24-year-old assistant at Lowell Observatory made history. Clyde Tombaugh had been systematically comparing photographic plates taken nights apart, looking for a moving object among fixed stars. After analysing approximately 2 million star images over 1 year, Tombaugh identified Pluto as a 15th magnitude point of light, shifting position between January 23rd and January 29th exposures. He described the moment with profound emotion. I suddenly came upon the images of Pluto. The experience was an intense thrill, because at that instant, I realized I was the first person in history, in all history, to know of the existence of Pluto. A tremendous wave of responsibility swept over me. Responsibility to do my work correctly and carefully, because this was something important. Discovery carries weight. Tombaugh felt it completely. The naming came from an unlikely source. 11-year-old Venetia Burney in Oxford, England, suggested the name Pluto, Roman god of the underworld. She mentioned it to her grandfather during breakfast, who forwarded the suggestion to Lowell Observatory. Chosen from over 1,000 suggestions because it honoured Percival Lowell's initials, P and L, while following mythological naming tradition. Venetia received £5 reward, approximately $300 today. For decades, Pluto remained the only known object in the trans-Neptunian region. Then, in 1951, Dutch-American astronomer Gerard Kuiper theoretically predicted a belt of icy debris beyond Neptune. He reasoned that leftover planetesimals from outer solar system formation should exist as a cometary reservoir. Ironically, Kuiper predicted this belt would no longer exist today, dispersed by planetary perturbations. But the region was eventually discovered and named in his honor. The breakthrough came after years of patient searching. Astronomers David Jewett and Jane Liu began systematic sky surveys in 1987 using the University of Hawaii's 2.2-meter telescope on Mauna Kea. 5 years of searching, night after night. On August 30th, 1992, they discovered the first Kuiper belt object beyond Pluto. Designated 1992 QB1, later named 15760 Albion, measuring approximately 160 kilometers in diameter. Jane Liu described the moment. There it was, a faint, fuzzy object moving against the star background. After 5 years of searching, after analyzing hundreds of thousands of stars, we'd found the first one. David and I just stared at each other. We knew immediately this wasn't just one object. This was proof of an entire population. The outer solar system was no longer empty space. Following initial discovery, hundreds of trans-Neptunian objects were identified within a decade. By 2000, approximately 400 Kuiper belt objects catalogued. Today, thousands are known. Discovery rate accelerated with improved telescopes and digital detectors, revealing the outer solar system's complex architecture. Each discovery added detail to our understanding of this vast frozen frontier. The Kuiper belt transformed from theoretical prediction to observable reality. But Pluto isn't alone out here. Other dwarf planets share this frigid realm, each with unique characteristics. Eris, slightly smaller than Pluto at 2,326 kilometers diameter, but 27% more massive. This mass difference, discovered in 2005, triggered Pluto's reclassification. Eris's higher density suggests its rocky core comprises a larger percentage of total mass than Pluto's. Currently 96 astronomical units from the Sun, 3 times Pluto's distance. Eris won't return to closest approach until the year 2256. 2 centuries in the future. Its 558-year orbit means it spends most of its time in the deep freeze beyond Pluto. At its current distance, the Sun provides 1/9000th the illumination Earth receives. Cold and darkness beyond our immediate comprehension. Yet this world exists, orbits patiently, preserves its frozen surface unchanged for billions of years. Makemake, third largest known Kuiper belt object, measures 1,430 kilometers diameter, 60% of Pluto's size. Discovered in 2005, named for Rapa Nui creation deity from Easter Island. surface covered in methane and ethane ices, appearing reddish-brown. One known moon, MK2, discovered in 2016, orbits at 21,000 kilometers distance. Another frozen world, another testament to the Kuiper belt's diversity. Then there's Haumea, perhaps the strangest dwarf planet of all. Elongated, shaped like a football, measuring approximately 2,000 by 1,600 by 1,000 kilometers. Rotating once every 3.9 hours. This is the fastest rotation of any known object, exceeding 100 kilometers diameter in the solar system. Rapid spin likely resulted from an ancient giant impact that also created two small moons and a family of smaller objects with similar compositions. In 2017, observers discovered something extraordinary. Haumea possesses a ring system. A narrow ring at 2,287 kilometers from its center, discovered via stellar occultation observations. This is the only known ring system around a dwarf planet. Ring particles orbit at 3-to-1 resonance with Haumea's rotation, preventing gravitational dispersion despite rapid spin. Even in the frozen darkness, physics creates beauty. The Kuiper belt structure reveals the solar system's complex history. Classical Kuiper belt objects, called Kuiper, named after the first discovered member, occupy nearly circular orbits between 42 and 48 astronomical units. Low inclinations, stable positions. These represent the least disturbed primordial population. They orbit exactly where they formed 4.6 billion years ago. Pristine remnants of planetary formation, unchanged by time. Many objects are locked in orbital resonances with Neptune. Plutinos, including Pluto itself, orbit twice for every 3 Neptune orbits, the 2-to-3 resonance. They complete 2 circuits, while Neptune completes 3. Maintaining stable orbital relationship for billions of years despite gravitational interactions. This isn't random distribution. This is gravitational architecture, sculpted by planetary migration over hundreds of millions of years. Scattered disk objects follow highly elliptical, tilted orbits, extending beyond the classical Kuiper belt. Likely scattered outward by gravitational encounters with Neptune during early solar system migration. Eris, one of the largest known dwarf planets, follows its 558-year orbit, ranging from 38 to 98 astronomical units, spending most time in the deep freeze beyond Pluto. These objects tell stories of ancient encounters, planetary migration, and cosmic billiards played billions of years ago. The nice model of solar system evolution explains this architecture. Theory proposes outer planets, Jupiter, Saturn, Uranus, and Neptune, formed closer to the Sun and migrated outward. Neptune's migration scattered the Proto-Kuiper belt, capturing some objects into resonances like the Plutinos, ejecting others to the scattered disk or interstellar space. This migration occurred 500 to 600 million years after solar system formation. Kuiper belt objects represent fossils of solar system formation. Too distant for the sun's heat to alter compositions, too far from massive planets for gravitational disruptions to shatter bodies through violent collisions. Chemical compositions, surface features, orbital arrangements preserve conditions from 4.6 billion years ago with minimal change. Studying the Kuiper belt reveals what the entire solar system looked like before planets cleared their zones and thermal processing altered inner regions. These frozen worlds are time capsules. Jupiter family comets, those with orbital periods less than 20 years, originate in the Kuiper belt. Gravitational perturbations occasionally knock objects inward, transforming stable Kuiper belt residents into active comets as the approaching sun heats ices, creating tails and comas. Even famous Halley's Comet, with its 76-year period, likely originated here. The Kuiper belt continuously supplies the inner solar system with visitors from the distant past. Spectroscopic analysis reveals varied compositions. Primarily water ice mixed with frozen methane, ammonia, nitrogen, and carbon compounds. Surface colors range from grey, water ice dominated, to red and brown from organic tholins created by cosmic ray irradiation, to bright white, fresh methane and nitrogen frost. Compositions vary based on formation location and thermal history. Each world tells its own story through color and chemistry. But the Kuiper belt contains far less mass than accretion models predict. Expected several Earth masses, observed perhaps 0.1 Earth masses. Possible explanations include mass ejection during planetary migration, or an undetected population of larger bodies, or formation conditions limiting initial accretion efficiency. The missing Kuiper belt mass remains an unsolved puzzle. Even after decades of study, mysteries persist. Now let's compare this region to other parts of the solar system. The asteroid belt occupies 2 to 3 astronomical units, containing rocky and metallic bodies. The Kuiper belt spans 30 to 50 astronomical units, 20 times wider. Contains icy bodies preserved in deep freeze, 20 to 200 times more massive than the asteroid belt, vastly larger and more pristinely preserved. Yet both are debris belts, remnants of planetary formation. Beyond the Kuiper belt lies the Oort cloud, forming a spherical shell surrounding the entire solar system, extending from 5,000 to 100,000 astronomical units. The Kuiper belt occupies a disc-shaped region in the ecliptic plane. The Oort cloud forms a sphere. 2 distinct comet reservoirs with different formation mechanisms. Oort cloud objects likely ejected from the inner solar system. Kuiper belt objects formed where they orbit now. And now we must address the controversy. The question that changed Pluto's status forever. In January 2005, Mike Brown's team at Palomar Observatory discovered Eris. Originally designated 2003 UB313, nicknamed Xena. Initial size estimates suggested larger than Pluto. Media dubbed it the 10th planet. But this discovery forced an impossible question. What is a planet? Mike Brown described his conflicted feelings. I was thrilled to find something larger than Pluto. And then I realized I'd killed Pluto. If this object was a planet, then anything that size would be a planet. And we'd eventually have dozens or hundreds. If we didn't call this a planet, Pluto couldn't be a planet either. There was no middle ground. On August 24th, 2006, after intense debate, the International Astronomical Union voted on a planetary definition. A new category, dwarf planet, was created. For bodies massive enough for self-gravity to achieve hydrostatic equilibrium, nearly round shape, but not massive enough to clear the orbital neighborhood of other objects. Pluto was reclassified from 9th planet to dwarf planet. 76 years of planetary status ended. The decision remains controversial. Alan Stan, principal investigator of the New Horizons mission, strongly opposes the reclassification. The IAU definition is scientifically indefensible. It doesn't depend on intrinsic properties. It depends on location. Put Earth where Pluto orbits, and by their definition, Earth isn't a planet anymore. Pluto is a planet by any geological or geophysical definition. The IAU got it wrong. Neil deGrasse Tyson, director of the Hayden Planetarium, offers a different perspective. I received hate mail. Children wrote me heartbreaking letters about how I killed Pluto. But science isn't about sentimentality. It's about categories that make physical sense. Calling it a dwarf planet doesn't diminish its importance. It increases our understanding of solar system architecture. Two perspectives, both from respected scientists. But whatever we call Pluto, one thing remained certain. Humanity needed to visit this distant world. New Horizons mission approval came in 2001, launch in 2006. Lifted off atop an Atlas V rocket on January 19, 2006. Achieving Earth relative velocity of 58,536 kilometers per hour. The fastest speed ever achieved by a human-made object leaving Earth. It crossed the Moon's orbital distance in just 9 hours. Apollo missions required 3 days. This demonstrated engineering advances in the half-century since the Apollo era. New Horizons wasn't just fast, it was unprecedented. A piano-sized spacecraft hurtling toward the edge of the solar system at speeds that defied previous exploration. On February 28, 2007, New Horizons flew past Jupiter at a distance of 2.3 million kilometers. Using the giant planet's gravity to increase velocity by 4 kilometers per second. 14,000 kilometers per hour added. This shortened the trip to Pluto by 3 years, arriving in 2015 instead of 2018. During flyby, the spacecraft tested instruments on Jupiter's moons, particularly Io's volcanoes and Europa's surface. Science returned during the cruise phase. To reduce operational costs and wear on components during the 8-year cruise, New Horizons spent approximately 2/3 of transit time in hibernation. Systems powered down except critical navigation and communications. The mission team woke the spacecraft annually for systems checks and course corrections, then returned it to sleep mode. Like the spacecraft, we too can rest during long journeys, conserving energy for the moment of arrival. After 9.5 years, after 5 billion kilometers, July 14th, 2015. New Horizons passed within 12,500 kilometers of Pluto's surface. Relative velocity 14 kilometers per second, 50,000 kilometers per hour. Too fast to orbit, but providing unprecedented views during brief encounter. Closest approach occurred 7:49 a.m. Eastern Daylight Time. Alice Bowman, Mission Operations Manager, described the tension. For 15 minutes during closest approach, New Horizons couldn't communicate. All antennas pointed at Pluto for maximum data collection. We waited hours in mission control for the signal saying, "I survived. I collected data. I'm healthy." When that signal arrived, the room erupted. Years of work, billions of kilometers, and our spacecraft threaded the needle perfectly. What New Horizons revealed changed everything. Not a dead, frozen world. Geologically active. Sputnik Planitia, a 1,000-kilometer wide nitrogen ice plain with convection cells. Surface age less than 100 million years, possibly as young as 10 million years. Recent or ongoing geological activity despite distance from the Sun. Internal heat, likely from radioactive decay and tidal interactions with Charon. Alan Stern expressed the triumph perfectly. We've traveled over 3 billion miles for this moment. Whether you call Pluto a planet or a dwarf planet, it's a geologically active world. With atmosphere, complex surface, and 5 moons. More complex than Mars. We're witnessing history today. Humanity reached Pluto, and we discovered its spectacular beyond imagination. This is why we explore. But the mission didn't end at Pluto. After Pluto's success, NASA extended the mission. New target, 2014 MU69, later named Arrokoth, at distance 43.4 astronomical units. January 1st, 2019. Most distant object ever visited, exceeding Pluto's record by 10%. Arrokoth revealed something extraordinary. A contact binary, 2 lobes gently merged, measuring 35.9 kilometers long. Pristine surface with no impact craters, indicating the Kuiper belt formation occurred via gentle accretion rather than violent collisions. Bodies grew slowly, touching gently, sticking together. Primordial assembly process preserved in a 36-kilometer frozen sculpture. Reddish color from organic tholins coating the surface. New Horizons continues outward. Currently traveling at 3.3 astronomical units per year. Studying cosmic dust and plasma environment of the outer solar system. Expected to function until approximately 2035 to 2038. When power supply and fuel reserves deplete, eventually will drift silently through interstellar space, carrying human artifacts into the cosmic deep. Clyde Tombaugh's ashes travel aboard New Horizons. The mission carried a small portion of the discoverer's remains. Tombaugh died in 1997, age 90, before the mission launched. An inscription reads, "Interred herein are remains of American Clyde W. Tombaugh, discoverer of Pluto and the solar system's third zone." He discovered Pluto from Earth's surface in 1930. His ashes reached Pluto in 2015. Now both continue outward together. Let yourself rest now. We've journeyed to the Twilight Zone, to the realm where sunlight fades to starlight, where temperatures hover near absolute zero, where frozen worlds preserve 4.6 billion years of history. We stand at the threshold between solar system and interstellar space, between warmth and cold, between light and darkness. The Kuiper belt extends around us. Hundreds of thousands of frozen worlds, each drifting in its centuries-long orbit. Pluto circles patiently. Eris orbits far beyond. Makemake, Haumea, countless unnamed bodies, all preserving the past, all waiting in the cold, all part of our solar system's ancient architecture. Consider the timescales. 250-year orbits. Only 18 orbits since the solar system formed. Human civilization spans 40 Pluto orbits. Your lifetime less than 1/3 of a single orbit. Yet we've reached this realm, understood it, connected with it. Rest in this achievement. Frozen preservation surrounds you. Chemical reactions cease. Molecules frozen in place. Impact craters persist for billions of years. This is the ultimate cosmic refrigerator, preserving primordial materials, allowing us to study the solar system's infancy by examining bodies that never evolved, never changed. Stand on Pluto in your imagination. The sun appears as a brilliant star, casting sharp shadows, but the sky remains black enough to see stars clearly. No blue atmospheric scattering, just darkness punctuated by solar light. Earth, if visible, appears as a faint blue star, requiring telescope to resolve. Home so distant now. Look outward from this frozen world. Chemical reactions cease. Molecules frozen in place. Impact craters persist for billions of years. This is the ultimate cosmic refrigerator, preserving primordial materials, allowing us to study the solar system's infancy by examining bodies that never evolved, never changed. Stand on Pluto in your imagination. The sun appears as a brilliant star, casting sharp shadows, but the sky remains black enough to see stars clearly. No blue atmospheric scattering, just darkness punctuated by solar light. Earth, if visible, appears as a faint blue star, requiring telescope to resolve. Home so distant now. Look outward from this frozen world. Thousands of Kuiper belt neighbours drifting, most invisible without telescope. Despite ranging from tens to thousands of kilometers in diameter, space between objects averages millions of kilometers. Not crowded, sparse, requiring precise navigation to encounter specific targets. Peaceful isolation. Each object drifts alone. Each object drifts alone. In cold and Lisa and darkness, completing centuries-long orbits, warmed only by faint internal heat, or star night. No weather, too cold for atmospheres. No erosion, no wind, no water, no change except rare impacts and slow geological processes. Time passes differently here. Seasons measured in decades, orbits in centuries, geological eras in billions of years. Yet despite unimaginable scales, distance, cold, time, humans reached this realm, photographed it, understood it. We're a species that explores. The Kuiper belt marks a boundary between what we call the solar system, planets, moons, warmth, complexity, and what lies beyond. Cold, darkness, simplicity, preservation. Standing here, we're at the threshold, still gravitationally bound to the sun, still receiving measurable sunlight, still part of the sun's family. But we can see the transition ahead. The gradual fade from solar system to interstellar space, from bound to free, from family to solitude. Scattered disk extending to 1,000 astronomical units. Inner Oort cloud at 5,000. Outer Oort cloud at 100,000. Then the space between stars. Statistical clustering suggests something extraordinary. A possible massive planet orbiting at 400 to to 800 astronomical units. Planet 9. 10,000 to 20,000 year orbital period. If it exists, it orbits in near total darkness. Sun merely a bright star, receiving 160,000th to 640,000th Earth's solar intensity. Search ongoing. The Kuiper belt drifts in cold and darkness. Thousands of frozen worlds, completing orbits that span centuries, preserving memories of solar systems formation, unchanged for billions of years. Patient, cold, eternal. We've visited one. Photographed another. Glimpsed a few more. But millions remain unseen. Each one a time capsule. Each one a fragment of cosmic history. Each one waiting in the darkness for the day we might return. Pluto continues its patient orbit. "248 years to complete one circuit. Since discovery in 1930, it hasn't yet returned to that position. Won't complete full orbit since discovery until 2178, century and a half in the future. Yet we wait with patience, cosmic patience. Eris circles far beyond. 558-year journey. Currently 96 astronomical units distant. Won't return to closest approach until 2256. 2 centuries in the future. These timescales dwarf human experience. Yet the worlds persist, orbiting patiently. New horizons sails outward. Carrying human touch in her twilight zone. .3 astronomical units per year. Expected to function until 2035. Then drift silently through interstellar space. Forever. A monument to human curiosity. Here at the edge, where warmth fades to cold, where light fades to darkness, where time stretches to geological patience. We rest in contemplation of distance, of time, of the peaceful darkness at solar system's edge. The frozen worlds keep watch. As they have for billions of years. As they will for billions more. Patient, cold, eternal, unchanging, preserving the ancient past in their frozen surfaces. Breathe with the time scales. One breath takes 4 seconds. One Pluto orbit takes 248 years, equivalent to 1.96 billion breaths. Yet both are real, both part of cosmic rhythm, human and planetary, connected across vast scales. For now, we rest. in contemplation of the Kuiper belt, in appreciation of the journey. 5 billion kilometers traveled in imagination, frozen worlds visited in thought, ancient history understood through science, human achievements celebrated in quiet wonder. Rest now. The Twilight zone surrounds you. Cold, but not hostile. Dark, but not empty. Remote, but not unreachable. Ancient, but not forgotten. The Kuiper belt, edge of the solar system. Threshold to interstellar space, home to frozen memories. Let the darkness embrace you. Not fearful darkness, peaceful darkness. The darkness of deep space, where frozen worlds drift, where time moves slowly, where preservation is eternal. Rest in this darkness. Pluto watches over you now. Heart-shaped Sputnik Planitia, nitrogen ice plains, mountains of water ice, 5 moons orbiting, Charon closest, all drifting together in their eternal dance through the cold. The solar system's edge. Where we rest tonight among frozen worlds. Patient orbits, ancient surfaces, cosmic preservation. peaceful isolation. The Kuiper belt, our distant frontier. Sleep now. In the twilight zone, where sunlight fades, where warmth gives way to cold, where time stretches beyond comprehension. Rest, drift, sleep. Frozen worlds drift. Patient, eternal, peaceful, cold, preserved, ancient. The Kuiper belt, watching over you. Rest at the edge. Solar system's boundary. Twilight zone. Frozen realm. Ancient memory. Peaceful darkness. Sleep. Distant, cold, ancient, preserved, patient, eternal. Rest. the Kuiper belt. Peaceful darkness, frozen worlds. Sleep now. Rest. Twilight Zone. Cold, dark, peaceful. Sleep. Frozen, ancient. Rest. Sleep. Drifting, peaceful. Sleep. Rest now. Sleep. Peace. Sleep. Rest. Peace. the edge of everything. Peaceful darkness. Rest now. Sleep. Frozen worlds drift eternally, patiently. Rest. Beyond Neptune, beyond warmth, into sleep. Rest. Pluto orbits silently. You rest. Sleep now. $5 billion kilometers from home. Safe. Peace. The Twilight Zone holds gently forever. Sleep. frozen memories, ancient worlds, peaceful rest, sleep. New horizons sails outward forever. Rest. The cold embraces gently, safely. Sleep. Eris watches. Makemake waits. You sleep. Rest. Edge of the solar system. Threshold. Peace. Sleep. Dwarf planets drifting, patient, eternal. Rest. frozen in time, preserved, ancient, sleep. The belt extends, vast, peaceful, rest. Kuiper belt, Twilight, rest, sleep. Cold darkness, perfect peace, deep rest.